Hi friends. So today we are going to discuss about proton pump inhibitor. The definition: the drug which are used to reduce or inhibited gastric acid production and secretion are known as proton pump inhibitor, that is PPI. They are more potent and longer duration of action as compared to H2 antagonist. They act irreversibly by blocking H plus K plus ATPase enzyme of gastric parietal cells. Mechanism: all the proton pump inhibitor contain sulfonyl group in bridge between substituted benzimidazole and pyridine ring. Under the influence of proton, it get charged into sulfuric acid and sulfonamide that react covalently with sulfonyl group that react covalently with sulfonyl group of cysteine of H plus K plus ATPase, that is hydrogen potassium ATPase enzyme, which inactive it irreversibly and thereby block the gastric acid secretion, especially when two molecule of omeprazole react with one molecule of enzyme. This is the mechanism for omeprazole, that when two omeprazole moiety get interact, then with the help of enzyme sulfonyl group that is present in cysteine, it get convert into this omeprazole active form, which reduce the gastric acid secretion. Medical uses: in peptic ulcer, stress gastritis ulcer, dyspepsia, stress gastritis, Barrett esophagus, and gastroesophageal reflux disease. Then we will see the SAR. This is a general structure for proton pump inhibitor. The example are omeprazole, lansoprazole, pantoprazole. The changes are occur at R1, R2, R3, R4 and X. If you have take a look on the structure, we can see the X is remain constant. That is, the X will be sulfonyl group mainly. So first one we will see. So the points of SAR, that is replacement of methoxy group by trimethyl group, increase the activity. Replacement of this R1, that is CH3 with trimethyl group, increase the activity of compound. Then replacement of methoxy by fluoromethyl. If we replace this methoxy by fluoromethyl, then it decreases the activity of that compound. Addition of difluoroaldehyde group at 6th position of omeprazole increase the activity. If we have added difluoroaldehyde group at 6th position, then it increase the activity of that compound. So first drug, that is omeprazole. It is a pro-type member of substituted benzimidazole, which inhibit the final common step in gastric acid secretion. Clinical uses: treatment of peptic ulcer, stress ulcer, bleeding peptic ulcer and gastroesophageal reflux disease, plus aspiration pneumonia. Dose: 20 mg once daily in peptic ulcer. The S enantiomer is slightly more active than its R enantiomer. The next drug, rabeprazole. This is a newer PPI. Is claimed to cause fastest acid suppression due to its higher pKa, and it is a more rapidly converted to the active species. Clinical uses, it used in gastric hypersecretory disorder. The mechanism of action for this is same as omeprazole. Dose 20 mg once daily. The next drug, lansoprazole. It is a proton pump inhibitor. The racemic mixture, that is 1:1 mixture of mixture of enantiomer, dexlansoprazole and levolansoprazole. Dexlansoprazole, it is a enantiomerically pure active ingredient of commercial drug as a result of enantiomeric shift. Clinical uses, used in treatment and prevention of stomach duodenum ulcer. Non-steroidal anti-inflammatory drug induce gastric ulcer, gastroesophageal reflux disease. Dose 15 to 13 mg once daily. Next example, pantoprazole. It is a newer hydrogen potassium ATPase inhibitor, similar in potency and clinical efficacy to omeprazole, but it is a more acid stable and has higher oral bioavailability. Clinical uses, Zollinger-Ellison syndrome, bleeding peptic ulcer, and prophylaxis of acute stress ulcer. The question asked in examination, that is structure of cimetidine and ranitidine, then what is a PPI and mechanism of action for PPI.